Hello everyone, I am Om Kakade and today I will be presenting on self-organizing maps, often called as SOM. This presentation explores how SOM, a type of unsupervised neural network, helps visualize and cluster complexes as well as high-dimensional data into a simple two-dimensional map. In other words, it's a technique that teaches machines to organize chaotic data into a meaningful patterns automatically. So let's get started. Self-organizing map, also known as Knonen map, was introduced by Tok Knonen. It works on principle of unsupervised learning, meaning it learns directly from unlabeled data without any prior training examples. SOM performs dimensionary reduction. It takes high-dimensional input vectors and projects them onto a two-dimensional grid, where each point represents a neuron. The key idea is computed learning where neurons compete to represent the input. The neuron that best matches a given input becomes the winner, and its weight along with its neighbors are adjusted to better reflect that input. So over time, this competition allows the network to self-organize and form a topological map that preserves data relationship in this. Let's look at the training process of SOM step by step. Step 1 is initialization. All neurons in the grid are initialized with small random weight vectors that matches the dimensions of the input data. Step 2 is finding the BME. Here is step 2. For each input vector, the algorithm calculates the distance between that input and each neuron's weights, usually using Euclidean distance formula. Neurons with the smallest distance is called best matching unit or BMU. Step 3 is updating weights. Once the BME is found, its weights and the weights of its neighboring neurons are updated to move slightly closer to the input vector. Step 4 is iteration and refinement. This process repeats for many training cycles. Gradually, the map organizes itself. Neurons from clusters and similar inputs end up closer together. Means they close each up to each other. That's how SOM transforms scattered high-dimensional data into a structured 2D representation. To see SOM in action, let's take a real-world marketing example as customer segmentation. Imagine a retail business with customer data containing features like age, annual income, and spending score. The SOM algorithm takes this multidimensional data and projects it into a 2D map. During training, it automatically groups similar customers into clusters. For instance, one region might represent high income, high spending customers, while other might represent budget conscious buyers. Marketers can then use these insights to design personalized campaign, identify loyal or at risk customers, and make data-driven decisions. In this way, SOM simplifies complex customer behaviors into clear visual patterns that business teams can easily understand and apply to their businesses. Strength of SOM lies in its visual clustering abilities. Each neuron on its grid acts as a cluster center, representing a group of similar data points. Because of SOM preserves topology, data points that are similar end up close together, while dissimilar ones are far apart. We can visualize this using a U matrix, which is called as unified distance matrix, which shows the distance between neighboring neurons. Darker regions indicates boundaries between clusters, while lighter regions shows dense similar groups. This transformation from random noise to organized clusters makes SOM a powerful visualization and pattern discovery tool which helps us. To conclude, self-organizing maps bridge the gap between complex data and human understanding. They transform high-dimensional data into an intuitive two-dimensional form while still preserving important relationships. SOM remains valuable for exploratory data analysis, pattern discovery, and anomaly detection across fields like marketing, biology, and finances, etc. Even today, the idea of competitive learning and topological mapping continues to inspire advance in deep learning and generative modeling. In essence, the self-organizing map is not just an algorithm, it's a way to teach machines how to organize and interpret the world around them, which helps humans. Thank you for listening.